Hey everyone, so in this video we want to start talking about something that we will cover in the next couple of videos as well, and that is collisions in simulations. So let's start with a simple setup, and this is a quick refresher on how to set up a simple PopNet. And we start with a sphere, so this is where our points should come from. And I create a dot network, and in here, and so it's collected to the first input, the sphere. And in here we need the three main ingredients: a pop solver, then a pop object where the points live in afterwards, or the particles, then a pop source where the particles will come from, and usually we also add a gravity so that something happens. Currently nothing happens because we first have to change the pop source, and we choose the first context geometry so that it comes from our first input. And if I start to play, and ideally with real time turn on, we can see that the points are emitted from the sphere, but we also see the strobing effect because all the points are falling with the same force, the gravity force, and therefore there is this repeating pattern. One way of solving this is by changing the substeps, which is a solution, and very often it's good to know that this can help us with getting rid of problems like this, but it's an expensive one because now everything is 3 times slower. And in this particular case, a better solution is to just make sure that not all the points start with the same speed of 0. And we can do this in a pop source under attributes, and we switch the initial velocity to set initial velocity, and then let's change the variance for x and z to 0, and maybe something smaller for y so that they have a different speed in y. And this is a better way of getting rid of the strobing effect, because now we don't have to slow down the simulation by using more substeps, but just changed the speed of each point. Now we bring in a ground plane, and as we've seen, a ground plane by itself we cannot just stick in, but we need to do that in combination with a merge. If I combine it like this, and I actually, let's move the sphere up a little bit so that it's actually not sitting in the ground. And even if I have now the ground plane in it and I press start, unfortunately it's not recognized. And the reason, of course, is that I forgot to switch the merge to mutual, because otherwise the order of the connection matters, and that's pretty annoying. So let's switch it to mutual, and all of a sudden the collision works and there's no point going through the ground. Great. What we want to do now as an addition is adding additional collision objects, not just the ground. And for this, let's start with a simple box. And I would recommend starting with a box because there's more to it that we have to talk about later. And with a box, you don't run into this problem instantly. So let's position our collision box somewhere here so that the points will hit it, something like this. And while we're at it, let's actually also create a second one by just copying our box. Did this with Alt, and then we merge them together, and we can use both as a collision. So I end up with something like this, and we take the whole thing from the merge and put it into the second input of our DOPNet. That's important, and let's remember that. And just connecting it doesn't do anything though, because if we go in, we can see there is no representation of our box, of our boxes that we just created. So how do we bring that in? And this is done with a very important node called the static object. Now keep in mind, this is not only for particles, so even if you find particles a bit boring and want to start doing other stuff, this will still be used in all the other stuff that is coming. So it's important to understand this properly. And we put the static object into the merge just like the ground plane, because you can see it doesn't have an input just like the ground plane. Now the static object we want to use to bring in the second input, right? So we would look for a way of bringing in the second context, just like with a pop source here, with a geometry source. But unfortunately there is no drop down. And this is important to understand. The static object is pretty old. So it doesn't have those convenient ways of, just using a drop down and choosing the second input. Unfortunately, we have to learn a very important expression to bring in what comes in from an input. But let's first look at alternative ways before we do this. And that is the sub path here. This is where we define what we want to use as a collision object. And we can just choose with this button here what we want to use. And since we know when we go back out that we wanted to use whatever comes out of the merge one, why not just choose this one directly? So I go into the subpath again and choose the merge one. There it is, accept, and as you can see, this worked totally fine, right? Now, I wouldn't recommend doing it this way for the following reason. What if I want to change it later on? Let's say I use a transform node afterwards, for example, and want to move the whole thing to the side. Easy, right? But the problem now is in my simulation, this hasn't changed. Why? Because the static object refers to this merge one and basically ignores what I did afterwards. Of course, I can now change this, but the problem is I have to now change it every single time I add something to my setup. Really annoying. So a better way could be, if you're clever, to say, okay, there will be a dedicated null, an out, as we've seen before, which is a very common workflow. So something like out collision or something, and we just refer to this node so that we can add nodes in between later on. And let's disconnect this for now because we don't need this in this kind of workflow. So we just find the out call, there it is, and we could also filter here, of course, to find it. And this would work, as you can see, quite well. So if we go back and change something like killing the transform, you can see this is now represented inside of our simulation. So this is great. This is a totally viable workflow, and a lot of people actually do that. But for a beginner, I would actually recommend using the inputs for the simple reason that it's easier to read. And I personally prefer that in my everyday work as well. I try to always directly connect all the things that are the input for .NET so that I can clearly see what goes into it via those connections. The problem with that now is, though, that we can't use this out anymore. I mean, we could. Theoretically, you can put a node in here. But more elegant would be to just say, okay, give me whatever is in the second input of the .NET. And this is what we want to use from now on. There is an expression, like I said, called OP input path. And the way it works is, and there's a separate video about this, so I do this a little bit faster now. We use two dots to say, please check for my parent node, so not the static object one, but the parent of it, which is the .NET one, where it lives in. And from that, take the second input, which is here represented with a 1, weirdly enough, because a computer starts counting at 0, not at 1. Therefore, the second input is 1. And now it still doesn't work. As you can see, it gives me an error because this is an expression in a string input. And therefore, we need those backticks so that Houdini understands that this is supposed to be code or an expression and not a path to an actual object. Now, this was a bit fast, I know, but there will be a whole video about this, so where I explain all the elements again, so no worries. So, and as you can see, this is the workflow that we use in this course at least, and you can see now there's actually a collision. Okay, I might have chosen the position a bit badly, but no problem. I can always go outside and adjust the position a little bit, like here, and if I rewind, this is now taken into account, and you can see the collision works for those two boxes. Small correction for me from the future. If you run the setup that you just saw that was created in Houdini 18.5, it will look something like this for you now. This is not your fault, you didn't do anything wrong, but in Houdini 19.5 something has changed, and that is in the pop object under physical, and we will talk about this in the next video, there is the friction parameter. And by default in Houdini 18.5 and 19, this was set to 0 by default. This is now by default set to 1, and this changes the behavior. So if you want to have the same behavior, just turn the friction to 0 and the whole thing will behave more or less like you saw it in the video. Don't worry, we will talk about this more in the next video, just for you to know so that you're not confused. So back to me from the past. So this is the core idea, using the static object node, combine it with a merge, use the OP input path to read out the second input, or any input you want really, for your collision object. This could be multiple objects that are combined, and this way you can see where everything is connected, and you can also change it whenever you want. And one last addition to this before we finish this video. Some people asked me what the static solver is doing, and maybe you've seen that because you were sneaky and used the shelf tools. And there the static solver is part of some setups, and it comes after the static object. And what the static solver is doing is literally nothing. And if you don't believe me, you can read in the help, it says the same. The static solver DOP is a solver which does nothing to its objects at each time step. So why does it exist? The core idea is that you have a way of turning it on and off. In practice, I've never used that, and I don't know anyone using it, because you can always, turn it off in other ways. So really, this is just a rudimentary node that I instantly delete because it does literally nothing to your simulation. So we talk about all those things and more in the next couple of videos. So far, I hope this was helpful. Thanks very much and see you later. Cheers.